Well, hi there, boys and girls. Today we're going to look at some inverse trig integrals, and we learned some things yesterday that should make two of them really easy. So let's start with something that should be really easy, and that is if I have the integral of u prime, or du, over the square root of 1 minus u squared, then this should be arcsine of u plus c. That should be your answer because we learned that derivative yesterday. Now, what are you going to do if there's a negative up here? Well, if there's a negative up here, you can just scoot it out to the front and call it still an arcsine integral with a negative on it. So we're not going to use arc cosine as any of our answers to integration. Oh, and by the way, just to make sure you have in your notes, make sure you have this correctly, not do it correctly in the video. At least, I wrote a tick mark when I meant to do a squared. The derivative of arc cosine of u should be negative u prime over the square root of 1 minus u squared. I think this is the part I messed up right here in my notes, so make sure you have that information down correctly. Okay, now another easy one would be if we have the integral of du over 1 plus u squared. Well, this should be an answer of arctan. We learned that yesterday. Now what we're going to do today is we're going to deal with situations where it's not so easy. Like, what if this is not a 1? That's going to be the hardest part. So let's go ahead and take a look at a more difficult example. What if I have the square root of dx over the, well, I probably said square root and I meant integral, and oh my goodness. Anyway, if I have the integral of dx over the square root of, let's say this was not a 1, let's say it's a 4. Okay, now here we have a problem. So I'm going to teach you how to deal with this problem, and then we'll develop a formula. First of all, unfortunately for us, that is not a 1. So I cannot use my straight antiderivative formula. So here's what I'm going to do. I'm going to do some fancy algebra. I am going to factor out of that square root, I'm going to pull out a 4, which would make this 1 minus x squared over 4. Now, if you don't believe that real quick, just distribute that 4 back through and you're going to see it looks like this. Then I'm going to take that square root of 4 all the way out in front of my integral. So then I've got the square root of 1 minus, now x squared over 4 can be written as x over 2 squared. Now let's perform this integration. Let's see if we can make it fit that form in the top. So u would then be x over 2. So what do we do next? Well, we take the derivative, right? So du is 1/2 dx. And I'm just substituting for that dx, so that statement would say that 2 du is equal to dx. So this would turn into 1/2 the integral of 2 du over the square root of 1 minus u squared. These would cancel, and I would get arcsine of u plus c, where u was x over 2. So it's arcsine of x over 2 plus c. Now that's the answer to the integral. Now that's pretty hard development, and there's a lot of algebra going on there. You don't have to do that algebra if you will embrace this formula. So here is your formula. If you have the integral of du over the square root of a squared minus u squared, your answer will be the arcsine of u over a plus c. Look how that worked in my example. It worked out to be x over 2, and I had this problem 4 minus x squared, so I could have fit this into this form. What squared gives you 4? Well, that would have been 2. And what squared gives you x squared? That would have been x. So my u is x. So it turns out to be the arcsine of u over a plus c. I'll show you an example of this in a minute. Okay, so that is definitely a formula you want to learn because you do not want to do all of that algebra like I did. I was just developing it for you. All right, now let's go to the arctan statement. What if I have the integral of 1 over 9 plus x squared dx? And this, again, is not a 1. Let me show you what to do, and then we'll still see a formula. Well, I'll go ahead and take and factor that 9 out. So if I factor a 9 out, this is 1 plus x squared over 9, and that's a dx. And I'll pull the 1/9 all the way out in front, and this turns into 1 over 1 plus x squared over 9 can be written as x over 3 squared dx. So I'm trying to make this fit my arctan rule. Alright, so my u would equal x over 3, so du is 1/3 dx. To substitute for that dx, I get 3 du equals dx. So this turns into 1/9 the integral of 3 du over 1 plus u squared. The 3 can come out here with a 9 and just make it 1/3. So this is 1/3 integral of du over 1 plus u squared, which turns into 1/3 arctan of u plus c, where u was x over 3. So this is 1/3 arctan of x over 3. So let's talk about a formula so you don't have to go through and do all of this algebra. If you are integrating du over a squared plus u squared, your answer is 1 over a times the arctan of u over a plus c. So let's see how that would have worked in my formula here. Or I'm sorry, in my problem. Here, this represents a squared, so a would be 3. This represents u squared, so u would be x. So my answer should be 1 over a times the arctan of u over a. So it worked out to be 1/3 arctan of x over 3 plus c. So this is a formula that you want to learn so you don't have to go through all of that algebra. So let's go take a look at a couple examples. This does not have a square root, so maybe this is an arctan integral. If this is an arctan integral, what is the value of a? Is it 16 or is it 4? Well, keep in mind this is a squared, so a is 4. And x squared, that's like your u squared, so u would be x. So this is an arctan integral because there's no square root. I've just got a squared plus u squared. So this should be 1 over a times the arctan of u over a, x over 4 plus c. That should be your answer, so you don't have to go through all of that algebra. So it looks like this answer is a. So that's not so bad as long as you learn the formula. Alright, so let's do one more. Here I'm going to take that 12 all the way out in front, and this has a square root with a minus sign inside of it, so this looks like it might be an arcsine integral. So on my arcsine integral, my a would be 4, remember it's the square root of this number, and my u would be x. So this will be 12 arcsine of u over a plus c. And that works out to be E right here. So I will see you guys tomorrow.